Okay, so we finished quiz number 8, and I may talk about that a little bit later. If you're working on in Rutledge, you need to stop the computer and finish the quiz 8 assignment before you pick up on the instructions today. Okay, important thing. This is important. Look up here. The extra credit project, the chapter 1 through 5 cumulative exam out of the book, is due at the start of class next week. Okay? It's due at the start of class next week. It is the beginning of your review for your midterm. So you need to make sure, it says it's due week 15, that is next week. Okay, so this week there's not a lot of new material that you're working on. You're working on the chapter 5 reviews to finish up chapter 5. When we get into lecture for next week, I'm going to try to explain logarithms. Logarithms sound crazy and hard, but they're not as hard as what they sound. It's not as hard as what it looks like. You just have to know the rules. Okay? So we're going to deal with that. All right, so make sure that you have those down. Now, one of the things that comes in with quadratic equations is the vertex form. Right? And one of the things that you're going to have to be able to do is you're going to be given an equation that starts with some value that's not 1, and you're going to have to create the vertex form. Now the vertex form in general looks like this. You have whatever constant you pull out of here. In this case it would be a what?
3.
A 3. When you pull the 3 out of the first 2 terms, and then you take half of the second term, that value, when it's a negative, is going to be the x of the vertex. So if it's with a minus sign here, the opposite of what you see there is the vertex number for x, and then the same number on this side will be the y, because normally it's y minus k equals, and this, but to bring it from this side to this side makes it positive. All right, and most of the time I like to give it like this, because this is how you generally do it, because you have either x, y equals 0 or something, or f of x here. All right, and so this is the form. So we have to pull the a out. Okay, now, in this case, the a is going to be 3, right, because that's the value with the x, and that's going to give me 1x squared in here. Now, if I can do this right, okay, so when I pull the 3 out of here and I pull the 3 out of here, I have x squared plus 8x left. Okay, now let's double check. What's 3 times x squared? 3x squared. What's 3 times 8x? 24x. And you notice, oh, I'm sorry, wait a minute. I changed the number. I didn't change it at the start. It's supposed to be 50. Okay? Alright, so now what I'm going to do is I'm going to create a perfect square with these 2 values. In order to do that, when x is 1, I'm taking half of this term. Right, now that's going to make my perfect square. So half of this is 4, and so now I have x plus 4 quantity squared. Because if I were to square this, I would have x squared, I would have a 16, and I would have 4x plus 4x, which is 8x. Okay, so that's my perfect square. Now, the extra number that's in here is 4 times 4 times 3, which is 48. Okay? That's the hard part about completing the square. Right? Because when you complete the square and you're not worried about this a number in front, which most of the time that's where the practice comes in, they practice with just an x squared out here. When you have the extra number for a, then the value that you're adding is much larger than, yes ma'am?
So you said to get 48, you would do 4 times 4 and then...
Right, 4 times 4, which is 16. Had there not been a 3 here, my third number would have been 16, because it would have been x times x for x squared, that's this, and then I would have 4 times 4, which was 16 on the end, and then 4x is 8x. But because I have a 3, I have 4 times 3, which is 48. Now, this already has a positive 48, so I need to add a negative 48 to keep my equation change at 0. Okay? And so when I finish, let me pull this all the way down here. When I finish, because it's 3 times 4 squared, 48, I have 3 x plus 4 quantity squared, and then 50 plus the negative 48 is a 2. Now I have the vertex form. Everybody see that? Now, in the vertex form, what do I know? Where's the x value? The x value is right here, opposite of this number, negative 4. So I have a negative 4, and then I have a positive 2, so that's my vertex. Negative 4, 2 is right here. Okay, now, the vertex is what? It's either the highest or the lowest point, depending on whether or not the parabola opens up or opens down. Which way does this parabola open? Oh, good question. Which way does it open?
It'll be up, right?
Up, because this is a positive value. Had this been negative 3, it would have opened down. Okay, so this opens up. Now, I want to talk just a second again about parent graphs. The parent graph for this is f of x equals x squared. So from here, if x moves 1, what is 1 squared? So normally, if x moves 1, I would be here. If x moved negative 1, what's negative 1 squared? It's also 1. Now what about 2? If x moves 2, what's 2 squared? 4. So if x goes 2, y? 1, 2, 3, 4. And if it goes negative 2 times negative 2 is still 1, 2, 3, 4. And so if you'll notice, the axis of symmetry, these points are symmetrically across this axis of x equals negative 4. Okay, now, that's true when x is 1, but when a is 1, but now my a is 3. So when I go over 1, I go up 1 squared times 3. What is 1 times 3? 3. So I'm up here now. And if I go back, I go 1 squared, 1 times 3, and I'm here. Now, what happens if I move 2? What's 2 squared? 4 times 3? 12. It's way up here. And then the same thing would be back here. And so my new parabola, based on this graph, is like this, and it's inside, which is called a stretch, because this regular parent graph was stretched out to be able to get these things to go up higher. So this is called a stretch. Okay? If this had been a fraction, then it would have pressed it down. That would have been called compressed. Right? Because let's say this was 1/3 instead of 1. Then I would have gone over 1 up 1 times 1/3, which would have been right here. And then I'd gone over 2, which would have been 4. 1/3 is 1 1/3, which would have been here. And my graph, my other graph at 1/3, would have looked like this, a big old fat thing. Okay, does it make sense? So in looking at plotting equations that are parabolas, you've got to be careful to make sure that the value of A is appropriate for what you're doing, okay? And so we didn't need this graph, and so this would have been the graph. Okay? Now, what did we do? Let's go back over that again. Get to it. All right, we started with the fact that this was not 1, so I had to factor this value, which was 3, out of both first and second terms. When I did that, I had x squared plus 8. Then you take half the second term and make the binomial square. Yes, Hannah?
If the 3 was a 1, and like, so it was just x squared, would you just skip the second step?
You'd skip this, right, because you already have it, and then you take half of the 24 and use to 12.
Right.
And then it would have been 12 squared, it would have been 144 added to that.
Okay, cool.
Yes, correct. Good question. Good question. All right, and then when we get the perfect square, we have to square this number, that's the third term, but it's this number times the 3 times the A, which would have been 48. So this has a positive 48 in it. I need to add a negative 48 to keep the change at 0. Okay, that's one of your problems for your midterm. That's one of the problems on the midterm. Find the perfect square, or I'm sorry, find the vertex form, and then after you get the vertex form, graphing it. Okay, now, I noticed that Forrester does not use parent graph that much. All right, and if you have where we're going, let's say that I have this. F of x equals 2 to the x power. All right, now I'm going to introduce where we're going in chapter 6, okay, just for a second. Okay, what is the value of this function when x is 0?
0.
1.
Oh, 2.
2 to the 0 power is 1. Somebody said it. So when x is 0, y is 1. It's right there. Now, what happens when x is 1? What is 2 to the first power?
2.
2. So when x is 1, y is 2. And when x is 2, 2 to the second power? 4. When x is 2, y is 4. When x is 3, y is 8. Okay? Now, let's go the other way. When x is negative 1, it's 1 over 2, which is 1/2. When x is negative 2, it's 1 over 4, 1/4. When x is 3, it's 1 over 8, 1/8. And what do you notice?
It's going down.
Y equals 0 is going to be an asymptote, and this is going to approach it, but it's never actually going to touch it.
Cool.
All right? And so now this is the equation of an exponent, or called an exponential function. And its key is right here. That when x is 0, y is 1. Now, what happens if I do this? I took this whole graph, moved it up 4, didn't I? Okay. And so this 1 is now up here at 5. And this line that was here is now an asymptote sitting here. And so this new graph looks like this.
Magic.
Okay? And this is how the different types of graphs are all changed. Now, we said that to say what happens with the quadratic graph. Let me change this. equals x squared when x is 0. When x is 1, y is 1. When x is 2, y is 4, and negative 4. And when x is 3, y is 9, and negative 9. All right, so here's my graph. Now, what happens if I put a negative 4 on the end? I take this thing and drop it down 4. Okay? And if I say this, x plus 2 squared minus 4, it's the opposite here, so that would move this over 2 and down 4, and my new graph would have a vertex right here. But as long as this is 1, this point is always over 1 up 1. And the second point is always over 2 up 4. All right, because this is the parent graph, and the second one starts here, right? Now, what would happen if I put a number in front of here? Then I'm either going to stretch it or compress it, depending on whether or not this is a fraction or whether it's a whole number. How can I flip it upside down?
Make it negative.
Make it negative. Then I would go over 1 down 1, and then over 2 down 4. And I'd have a graph looking like this. Okay? So, when you are completing the square, you're trying to get either this form or this form so that you know where the vertex is, and then depending on what the value of A is, you're either going to have over 1 up 1 or 1 times whatever that A value is.
Right.
That's how it changes. Does that make sense? Now, I don't see Forrester, that's the book author, he doesn't go into the graphing of it that strongly. Right, some of the other books I've used in the past, I spend more time doing the graphing. So I hope that that helps a little bit. Okay? All right, now. Whoops. Let's see, I've got one more thing I got to find here. Is it in here? Here it is. Okay, we'll look at some of the other things that you're going to have on the homework. Oh, I know what I wanted to do. Right there it is. Okay, now, here's a question. Can this equal negative 8? That's the question. All right, now, if you have this function, if it equals negative 8, that means the y is negative 8. Right, now, that's the key to that type of question. The next 2 sessions that you're going to be working with, there is a problem in the text that asks you, can this quadratic equal, and it gives you a number. Okay? Now, from a purely mathematics standpoint, what it's asking you is, can this equal that? Right now, that's the start of the process of trying to figure it out. Normally, for a quadratic equation, if the value of y equals 0, we can use the quadratic formula. Right? So, is this set up to use the quadratic formula? The answer is no. What do I have to do? You got to move the negative 8 over this side by adding 8. Well, when I add 8 here, this is going to become plus 5. All right? Now, my determinant, the value under the square root, will tell me what kind of equations I've got. If you remember, if b squared minus 4ac, if it's positive, then you have real numbers, right? If it's a perfect square, then you have rational numbers. If it's not a perfect square, you have irrational numbers, right? What happens if it's 0? If this makes 0, you have one dual rational number, because it'll be negative b plus 0, negative b minus 0. It's the same value over 2a. All right? And then the third thing will be what happens when it's negative. You have an imaginary number. And so what I have to do here is I have to check this and see whether or not it's positive or negative. So what is b squared minus 4ac?
Negative 15.
It's 25 minus 4 times 10, which is negative 15. And because it's imaginary, then no, it cannot equal negative 8. That's all it's asking. That's all it's asking. Now, does it make sense what the question is? Okay? The question is, can this equation ever equal this number? All right? After you set it up and change it back to where it's 0 so that you can use your quadratic formula, then you just find out what the determinant is. That's the reason that they taught you the determinant, is so you can determine whether or not you even need to proceed. Right? And when we found that this ended up being a negative number, then I know that I can't get a real number, and so therefore I'm done with that particular problem. All right, does that make sense? Okay, now, and as I said, there are several, in the next couple of sections that you're assigned, there are several different ways that that's presented. But all it's asking you to do is to use your determinant after you set this equal to 0. Okay? All right, now, all right, the other thing that I saw on this last problem I want to go back over just in case is, let's see, how am I going to do this? Why didn't it work? There. Okay. Two, 7, 4, 11. How do you create the graph that goes through those 2 points? All right, first of all, what kind of graph is it?
Linear plus.
It's linear. It's linear. Okay, so what's the general equation using letters?
Y equals mx plus b.
Y equals mx plus b. Now, I have an x and a y. In fact, I got 2 x's and 2 y's. So I have an x and a y. I need to find the m and the b. All right, the m is easy.
Yeah.
Maybe.
It's
All right, so how do I find the m?
Difference of the 2 y's.
Right, it's the change in the y over the change in the x. So, how far apart is 7 and 11?
4.
4. So if I start at 7 and go to 11, I'm going plus 4. If I start at 2 and go to 4, I'm going plus 2. So what is?
It's 4.
So the slope is?
2.
Slope is 2. So now I have that. And then all I have to do is just put these in here. So I have 7 equals 2 times 2 plus b. Or I could have said 11 equals 4 times 2 plus b. Alright? This is 4. 4 plus 1 is 7. Tree, right? Right? 4 plus tree?
Yeah.
7. And what over here? 8 plus tree is 11.
Yeah.
So what is B?
Tree.
B is tree. So therefore, I have y equals 2x plus tree. That's the equation.
That's lovely.
Right? Now, how do I make it harder? I make this 5. What's that do to my slope?
It makes the x negative.
It makes this down 1,
Which equals negative.
right?
No, equals negative.
So that'll make that slope negative 4, right? And so if this is negative 4, now I have negative 8 plus how much is 7?
15.
B is 15. Right, so math can change with just one little change in slope. But this y equals mx plus b is whatever it is. Okay? All right, now that is a problem on your test.
Midterm?
Well, it's on your review test for this week.
Oh, okay. That's not terrible.
Let's see. What did I do? I put it on there, this. All right, any specific questions that you've got? Okay, all right. Let me look at this one more time, make sure. Okay, here's what I'd like you to do. I want you to draw a coordinate plane, just basically like that. Okay, now, so here's my question. Where is the vertex? Where's the vertex of that equation? Yes, it would be. Very good. Very good. All right, opposite of this, same as this. So the vertex is at 1, 3. Okay? Which is going to be 1, and then 1, 2, 3. All right here. Okay? Now, axis of symmetry is going to be x equals 1. That is a dashed line right through there. That's the axis of symmetry, right? Put that on your paper. All right, now, what happens in this case, right? If I multiply this out, I have 1 times 2. Right? So that's going to make 2 plus 3, that's going to make a 5. And what I'm going to do is I'm going to multiply this out and show you. This is 2x squared, and that's going to be minus 2, so minus 4x plus 2 plus 3. Can you see that makes 5? So when x is 0, y is 5. That's right here. All right, that's called the y-intercept. Now, here's my question. How far is it from the y-intercept to the line of symmetry? 1 unit, right? And so the symmetrical part will be 1 unit on the other side. Which is going to be right here. All right, now, that is another skill that your text wants you to be able to do. Given the vertex and the y-intercept, draw the graph. Well, what you're going to do is you're going to see that this vertex and this y-intercept is the left part of the parabola, and so the right part of the parabola has to be symmetrical.
Right.
So whatever this distance is, you're going to put it on that side and then draw the graph. Now here's what I want to show you. What's my multiplier? My a is 2, right? Normally it's over 1 up 1, but now it's over 1 up 1 times 2. Over 1 up 1, 2 is that point. Okay? What would happen if it would have been 2 apart? It normally would have been over 2 up 4, 2 squared, but it had been up 4 times 2, it had been up 8. Right? And so if I had been up there, if it had been over 2, I'd been way up here. So this is 2, but it would have been 8 above this point. Right? The parent graph plotted and the symmetrical part of the graph all work together. Right? But what your text is asking is, given this point and this point, you have to find the reflection. Right? And that should, hopefully, if you understand what I just showed you, that should help you be able to answer that question. Because it asks you to graph this. Well, if you have this point and you know that that's the line of symmetry, you should be able to do the graph fairly easily. Okay? And then the same thing you can do, if I didn't give you this point and you just knew this, you could also plot it. Because it would be over 1 up 1 times 2. Over 2 up 4 times 2. Okay? Does that make sense? Okay. What time is it? 20. Wow. Man, that's going fast. Okay. All right, let's see. All right, now, last thing I want to go over is the 3 different types of graphs. All right. If I were to give you a graph that looked like this, what is the solution to this graph? The solution is this point and this point, where the graph, because this line is where y equals 0. Right? This line here, y is equal to 0 on the x-axis. Isn't that what we set the equation to equal? Right? The quadratic equation equals 0. If the y equals 0, it's that point. And so if the question asks what are the x-intercepts, it's talking about the solutions. It's the solutions when y equals 0. All right, so how many solutions are there? 2. Everybody agree? Okay, suppose that I had this. How many solutions is here? 1. And that means that the discriminant is 0, so that it's negative b plus 0, negative b minus 0. This one has a positive value, so that it's basically negative 5 plus some number, negative 5 minus some number. Okay? What will the imaginary one look like?
It'll start in the middle.
Start up here and go like this. Or it starts down here and goes like this, so that it doesn't cross the x-axis at all. Okay? So if it has one solution, it's going to be sitting on the x-axis at that solution. Right, that's called a dual root. If it has more than one, right, then it's going to be cutting it twice. And if it's got none, because it's imaginary, it's either going to be above it or below it and going in the opposite direction.
Great.
Right? Okay, so what's your assignment? You have the section, I think is what, 5.7, whatever it is, the cumulative review.
5.9.
5.9, sorry, thank you. Let me get this again here. Yeah. You got the chapter 1 through 5 review, and I'm going to give you a chapter quiz. Most of what we have gone over today have been problems from that chapter quiz, so that it's not a surprise. It's just you have to demonstrate that you can figure it out. Okay, questions? All right, okay. Have a wonderful day.